Good morning, college algebra students. Now, as you're watching this video, it may not be morning, but as I'm recording this video, it's a beautiful spring day. So I'm going to tell you good morning, or perhaps good afternoon, or good evening. In the last video, section 1.2, we practiced multiplying polynomials. In section 1.3, we're going to do exactly the opposite, that is, factor polynomials. We'll study different factoring techniques, including factoring out the greatest common factor, factoring by grouping, factoring binomials, and trinomials of all kind. So let's get started with our first technique, factoring out the GCF. The greatest common factor, which we abbreviate GCF, not to be confused with the LCD, lowest common denominator, which is a common multiple. The greatest common factor, GCF, of two numbers is the largest positive integer that evenly divides each number. For example, while 2 is a common factor of 4 and 24, because both 4 and 24 are divisible by 2, 4 is the greatest common factor. It's the biggest number that evenly divides both 4 and 24. Note, when finding the greatest common factor of terms containing variables, we're going to include the lowest power of the common variable in the GCF. So it's kind of confusing to your brain sometimes. We're looking for the greatest common factor, but this is going to include the lowest power of the common variable. So let's try a couple of examples. Example 1, factor the following polynomials by extracting the GCF greatest common factor. In example A, we have a trinomial 6x squared plus 12x minus 36. So I'm going to look at all three of those terms and determine if they have a greatest common factor. Hopefully you can recognize the GCF here is 6. When we identify the GCF, we're going to extract it over here on the left. Then I'm going to open up a set of parentheses and anticipate 3 terms in this set of parentheses. The original polynomial had 3 terms. I'm going to divide all 3 terms by 6 and see what's left. So that first term, 6x squared divided by 6, leaves behind an x squared. 12x divided by 6 leaves behind a positive 2x, and 36 divided by 6 leaves behind minus 6. So we say this one has been factored. Now, anytime you factor, you can immediately turn around and multiply to check your work. So to check my work, I'm going to take that greatest common factor, 6, and redistribute it just to make sure that I did it right. So we have 6 times x squared, which is 6x squared, plus 6 times 2x, which gives me 12x, and 6 times negative 6, which gives me negative 36. Notice that matches the original trinomial exactly, so we can be confident that we did it right. One of the things I love about mathematics is how black and white it is. There's not a lot of ambiguity. We worked the problem, but because we were able to check the problem, we could verify on our own that we did it right. Okay, let's try another example. We have the trinomial 3x cubed minus 6x squared plus 9x. So I'm going to take one thing at a time and look at the coefficients 3, 6, and 9 and observe the greatest common factor there is 3. So I'm going to put that into my GCF. But also notice all terms have at least x to the power of 1. Remember, we include the lowest power of the common variable in the GCF. The lowest power that we have in common here is x to the first power. So our GCF in this case is 3x. I'm going to open up a set of parentheses and anticipate 3 terms remaining. So we have to figure out what can I multiply 3x by in order to get 3x cubed. Remember, when we're multiplying like bases, we add the exponents. So because I can take the exponent 1 and add it to the exponent 2, that gives me the correct exponent 3. Next term is negative. If I take negative 6 divided by 3, that gives me negative 2. And if we take x squared divided by x, that leaves behind x to the power of 1. And finally, 9 divided by 3 is 3. We've already got x to the power of 1 in that term. So in this case, we have factored out the GCF. But again, it's always a good discipline to build to learn how to check your work. So I'm going to double check by doing the opposite, which is multiplication. So 3x times x squared gives me 3x cubed. 3x times negative 2x gives me negative 6x squared. And finally, 3x times 3 gives me 9x. That matches the original problem exactly, so we've done it right. Now, this is our answer, and that was our check step. So what we have in the box there is our final conclusion. Okay, one last example. We have 3 terms in this polynomial. Notice all 3 terms contain both an x and a y. The coefficients don't have anything in common other than 1, so our GCF will have a coefficient of 1. But let's look at just the x parts first. We're going to take out the lowest power of x that they have in common, which in this case is x squared, and notice all 3 terms have a y. So we have a multivariable GCF here. Now, if I divide that from all 3 terms, we can anticipate 3 terms remaining. So if I take that first term, x to the 4th y, and divide it by x squared y, that leaves behind x squared. Next, we're going to need a coefficient of 2. We're trying to generate x to the 3rd times y. We've already got the y in our GCF, so we need one more power of x there. And finally, the last term, x squared y, matches our GCF. So if I think divide x squared y divided by x squared y, I end up with 1. So that is our factored polynomial. To be sure, let's double check with multiplication. This not only will verify our answer, but it'll give us a little bit more practice with multiplication. So x squared y times x squared gives me x to the 4th y. Remember, we're adding exponents on like bases. X squared y times 2x gives me 2x to the 3rd y. And x squared y times negative 1 gives me negative x squared y. Factoring out the GCF is always going to be the first thing you look for when you attempt to factor a polynomial. We'll look at another technique in the next video.